Recording. All right, today we're finding vertical and horizontal points of tangency, among a few other things. So we have this graph, r equals -1 plus cosine of theta. And let's not pretend we have no idea where it is. Horizontal is actually at pi over 3. We put these at nice places, and I imagine if this was ever on an AP test that they would have it as at pi over 3s and pi over 4s and pi over 6s, the ones that we know. I doubt an answer would be 7 pi over 31, nothing crazy like that. So we got a horizontal at pi over 3, another horizontal at 5 pi over 3, and then we got vertical, I think at 2 pi over 3 is vertical there. Vertical at, was that 4 pi over 3? Another vertical over here at 0. So we got those, and then there's one at the cusp right here. There's a cusp on this cardioid. If you look as we're approaching this value, the slopes tend to be leveling out, right? Not only from above, but if you put a slope here and a slope here, they tend to be leveling out. So there's actually a horizontal slope right there. The problem is that value will occur on both lists, on the list for the horizontal and on the list for the vertical. And we got to show that it's actually horizontal, but we'll deal with that when we get there. In our toolbox, we had x equals r cosine, and we had y is equal to r sine. And that's how you convert from polar to rectangular or vice versa. So in our case, the r is -1 plus cosine. So we have -1 plus cosine of theta, and then cosine theta. And y is -1 plus cosine theta, and then sine theta for y. So there's the conversion. Throw the r in. We know what r is. Now we need dy dx, because we need the slope of the tangent lines. And we're going to set the top equal to 0 and the bottom equal to 0. All right, so the derivative of y is first times the derivative of the second plus the second times the derivative of the first. Now we need that over the derivative of x. So we have first times the derivative of the second. I'm doing x now, so negative sine of theta plus second times the derivative of the first. Let's simplify it. Negative cosine plus cosine squared minus sine squared. And then we have sine minus sine cosine minus sine cosine. This is negative cosine plus cosine of 2 theta. That is the double angle formula for cosine. Over, well, let's write it like this. Minus 2 sine cosine. These are exactly the same. One more line and then we're ready to split it up. This right here is the double angle formula for sine. We have sine minus, not 2, sine minus sine of 2 theta. Now we're ready to split this up. So we have, now remember this is derivative. This is dy dx, remember. So we have horizontal, which we set the top equal to 0. And we have vertical, which we set the bottom equal to 0. Now I have some hints to get these answers using your calculator, so I recommend grabbing your calculator. Now we're solving these as a single equation. So we don't really want to be in parametric, we don't want to be in polar, we want to be in just function mode. Function. Because we're going to solve these individually, one at a time. All right, we'll go to y equals. And how about the first one? Negative cosine plus cosine of 2x. Now, like I said, you're not going to see crazy answers for this. You're going to see the values that we know. And what we know are pi over 2s, pi over 3s, pi over 4s, pi over 6s. And the common denominator of that is pi over 12. So we're going to do this from 0 to 2 pi. But we're going to go by pi over 12s. That way we can just count by 12ths. And if it's a pi over 4, it'll reduce to pi over 4 and reduce to a pi over 3 or whatever we need. And negative 2 to 2 seems to be good for both of these, actually. So we're ready to go. So theta, first of all, 0. 0 seems to be 0. 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8 pi over 12. 9, 10, 11, 12, 13, 14, 15, 16. 16 pi over 12, and then 2 pi. But we already got 0, so we don't need both of those. Everybody good? Getting your calculator to work and everything? All right, we'll go to y equals. Clear that out. Sine of x minus sine of 2x. And the trick is gone by pi over 12s. I think it makes it a lot easier to just find these values, and then we'll just count. 0. 0 appears in both parts, so we have to deal with that. So theta is equal to 0, 4 pi over 12, 5, 6, 7, 8, 9, 10, 11, 12. 12 pi over 12. And if you're not sure, if you're counting, you're not sure you're counting right, you can always go second, calculate a value. 12 pi over 12 is pi. So you can always check pi, and you'll see that actually 0 if you ever want to check any of these. 13, 14, 15, 16, 17, 18, 19, 20. Looks like 20 pi over 12. And you can check that. You can go 20 pi divided by 12. That should say 0. So there's 0. All right, well, we got our values, but we have a problem. We got 0 listed in both of those, and the reason is because there's a cusp there. That's why it appears in both. So, and we know it's horizontal, but how are we going to show that it's horizontal? You got any ideas? Not a bad idea, but no. Yeah, what do you think? A what? I can't hear you. Oh, so you're talking about limits, right? Because we're approaching that slope, aren't we? That's kind of how I drew it. We're approaching it. But you're kind of ahead of the game a little bit. We're going to go limit as, what do you think? Limit is what? Yeah, theta approaches 0. Of what? What are we taking the limit of? Yeah, dy dx. We're seeing what's the limit of the slope as theta approaches 0. Very good. So negative cosine plus cosine of 2 theta over sine of theta minus sine of 2 theta. Let's plug that in and see what we get. Cosine of 0 is 1, so negative 1 plus. Cosine of 0 is 1. Sine of 0 is 0. Sine of 0 is 0. So you're right, we're going to do L'Hopital's, but you're kind of ahead of the game a little bit. Got an indeterminate form, so we're going to use L'Hopital's. Limit as theta approaches 0 of sine minus 2 sine of 2 theta. We're doing derivative, remember, over cosine minus 2 cosine of 2 theta. There's the derivative. And back off and check that. Yeah, that looks right to me. Now sine of 0 is 0. Sine of 0 is 0. Cosine of 0 is 1. Cosine of 0 is 1. So 0 over negative 1, that is not an indeterminate form. That's 0. So we just showed that it belongs in the horizontal. It does not belong in the vertical, so I'll just cross that out. When you do your work, I kind of want to see that you got 0, but then I want to see that you know it shouldn't be there. So we'll just cross it out. All right, now we got to find the points. So let's label this horizontal. Something comma 0. Something comma 2 pi over 3. Something comma 4 pi over 3. Well, now we're going to plug those thetas back into the original. Negative 1 plus cosine, I'll make a note it's negative 1 plus cosine. So I don't have to keep scrolling up there. Cosine of 0 is 1, so that's 0. Well, yeah, that's that point right there. That's this point. That's 0, 0. 2 pi over 3. Cosine of 2 pi over 3 is negative 1, so negative 3 halves. So when we're up at 2 pi over 3, 2 pi over 3, we're actually talking about this one down here, where it's horizontal. So that's that one. And then 4 pi over 3 is also negative 1 half, so negative 3 halves. So then we have vertical. I'll get out of the way. Vertical is pi over 3. Pi, 20, let's see, 4 goes in there, 5/3. 5 pi over 3. So there's the 3 points that we want for vertical. Cosine of pi over 3 is a half, so that's negative 1 half. Cosine of pi is negative 1, so that's negative 2. And then cosine of 5 pi over 3, that's a half also. There we go, and we're done. Now that's a calculus problem, boys and girls. That's a good one. Look at all that. Trig, L'Hopital's, polar, vertical, horizontal. Not much more we could jam into that one if we tried. Any questions on the concepts, on the problems, on how to do it? A lot to do, a lot to keep track of. Find the equation of the tangent line at the tip of the petal in quadrant 1 of this rose here, if r equals 5 sine 2 theta. Well, we better find out where that is. Let's graph it, but we don't have to do the whole graph. We're just finding the tip of the petal in the first quadrant. That's all we have to do. We don't have to graph any more than that. So if we go theta and r, how about we count by pi over 4s, 1/4, 2/4, and that's really all the farther we need to go. Matter of fact, I probably didn't need to go that far. Sine of 0 is 0. Pi over 2 is 1. So that's 5. Pi is 0. So we're going to go 0, 0. Pi over 4 is out to 5. I already know that's the tip of it. But then back here is the full petal. So there's the point right there. So we're looking where theta is equal to pi over 4. So we found out where we are. X is equal to r cosine. Y is equal to r sine. Should we get the point first? Because we need a point and we need a slope. You ever seen me write that? Only 100 times. So the point is, let's see, if I plug pi over 4 in, evaluated at theta equals pi over 4. 5 times sine of pi over 2 is 1. Cosine of pi over 4 is square root of 2 over 2. So that's 5 square root of 2 over 2, and because it's at pi over 4, this has got to be the same thing. Now the slope. dy over dx is equal to. Any guesses as to what the slope is? What do you think it's going to be? Negative, it's -1. Yeah, it's -1, that's right. Because you got this 45-degree angle here, that's 1. That slope's -1. But let's get it. First times the derivative of second plus the second times the derivative of the first. dx is first times the derivative of second plus second times the derivative of the first. Science is out in the halls having fun. How dare they? How dare they have fun in class? Oh boy, pi over 4. Sine of pi over 2 is 1. Cosine of pi over 2 is square root of 2 over 2. Sine of pi over, where are we at? Pi over 4? Sine of pi over 4 is square root of 2 over 2. But cosine of pi over 2 is 0, so that just became 0. 5, sine of pi over 2 is 1, but negative sine of pi over 4 is negative square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2, but cosine of pi over 2 is 0. So both of these become 0. Those are exactly the same with the exception of the negative, so there's your slope of -1. So y minus 5 square root of 2 over 2 is equal to -1. X minus 5 square root of 2 over 2. I think I closed it, but I want to show you this. I'll go back to it, okay? If you're still writing, I'll go back to it. Did I leave? Oh, I left it open. Good. I don't have to take the time to do it. There it is. Perfect, isn't it? It's absolutely perfect. It works. There's the graph. There's the one pedal. There's the tangent line. All right, if you're still writing, there it is. Imagine the journey that you've been on to get to that point, to be able to at least, maybe not do this right now, but at least to comprehend something like that. Pretty amazing, isn't it? It's come a long way. Long way. What is the slope of the polar curve at theta equals pi? Give that one a try. Are you catching on? Do you want to sit over there from now on? Yeah. Yes. Should have said something. Yeah, you're going to get blinded. Yeah. we start with, the conversion between x and y. So dy dx is first times the derivative of the second plus the second times the derivative of the first. That's dy. Did I do dy or did I do, yeah, I did first. Oh, did I do dx? Gosh darn it. Yeah, don't make that mistake. That would have been upside down. I got to do dy. First times the derivative of the, there we go, plus second times the derivative of the first. My apologies if you were watching. There we go. Make sure you do dy, not dx. So dy over dx. I'm glad I caught that. First times the derivative of the second plus the second times the derivative of the first. And we're evaluating this when theta is equal to pi. So 3 over pi, cosine of pi is -1. Sine of pi is 0, and this would be -3 over pi squared, but it's just going to be 0. 3 over pi, sine of pi is 0, so this is 0. Cosine of pi is -1, and then -3 over pi squared. So that goes, that goes. Negative over a positive is a negative, so that's -3 over pi over 3 over pi squared. Well, instead of dividing, how about we multiply by the reciprocal? So instead of doing that, multiply by the reciprocal, it ends up being -pi. Which I don't know, seems reasonable. Here's the tangent line. And if we go, I know it's off the map a little bit, but if we go up 1, 2, 3, and over 1, that seems reasonable. But not only that, you don't have to do this. Here, I'll show you real quick. If you go to polar, put in 3 divided by theta. I changed the window. What was my window? Pi over 2 to 2 pi. -2 to 2, -2 to 2. How about we do that? Graph. There's the graph, roughly. And if you go second, calculate the derivative right here, 2, at pi, -pi. So there it is right there, -pi. So you could quickly do this with a calculator, very quickly. Any questions on this? We're going to get into a little review, but that's pretty much it. There's not really, look how many days we're spending on 10.3. We're trying to go very slowly for you, very slowly, considering how many days we usually spend on a section. So today there's big problems, that's a lot, but not very many types. This is finding horizontal and vertical. This is finding the slope of our equation of a tangent line at a specific spot. That's why you kind of have to know the graphs, right? You got to know a little bit about them to find that spot. And then what if we just say, all right, what's the slope at pi over 3 or pi over 6 or pi? So we probably went from the hardest down to the easiest, in my opinion. Any questions on anything we've done so far on these 3 slides? Seem to be, just got to practice them right now. Well, there's not much to it, so I thought that would give us a chance to do a little review. So talk with your partners. Can we go with A, B, and C? Help each other out if you would. Compare answers. Why don't you just keep going? I'll try to just lag behind you. Just keep going with this one. Help each other out. Check answers. See if you're getting the same answers. I'll try to just lag behind. If you got questions, let me know. Yeah, E's a doozy. Coordinate. Oh, I messed that up. Oh, I don't want that. $26. All right, if I can get your attention just really quick on this one. I made this problem, and then I wanted to ask as many questions as I could about it. So we get a lot of review in. And someone first hour pointed out that you don't really have to use calculus for letter D. And then I pointed out that if there's actually on a test, I wouldn't give you that. I'd give you the derivative. So what do we mean? Well, if you want the position, that is the position. So if you plug 3 into this, you get 27 minus 3 is 24, but you started at 2, so you'd add 2. You could still get 26 and never do calculus on it. But if this was actually on the test, we wouldn't give you the position function, we'd give you the derivative, so you'd have to do integral. All right, so I don't know if any of you caught that, but that's just because I wrote the problem and I wanted to ask as many questions as I could. All right, E has some work to be done because of the quotient rule, really. So the first derivative, and I didn't leave even close to enough room for this. So we have cosine of t over 3t squared minus 1. So there's first derivative. Second derivative is derivative of first derivative, except like we've talked about with the extra dx dt at the bottom. So bottom, oh, I'm not going to have nearly enough room. Bottom times derivative of the top minus top, oh, I might, times the derivative of the bottom, 6t over the bottom squared, over dx dt again. That's a little extra piece. That's why I included this in there, to remind you one more time that you need the extra piece in there. And I'll probably remind you one more time before the test. But we're evaluating this at 3. So d2y over dx2 is equal to, what do we got, 27 minus 1, 26 sine of 3. It ends up being an ugly answer. Minus cosine of 3 times 18 over, this ends up being to the third. So 26 to the third. Some decimal value, of course, so we might as well finish it up. Sine of 3 minus cosine of 3 times 18 and divide by 26 to the third. Oh, that's not what I got. That's not the answer. Where did I mess up? Anybody see it? Bottom times derivative of top minus top times derivative of the bottom. Shoot. Oh, bottom derivative, that would be negative sign. Thank you. Just make that, we'll just insert negative, divide by 26 to the third. That's the answer. 2, 3, 805. All right, hey, let's try the limit one, all right? Help each other out, remind each other what to do. See if you can come up with this one. You get done already? What'd you get? Did you get 1? Yeah, good job. So I did it all in one shot there. I mean, as far as that first line, we can kind of build to it. We make f of x equal to the function. We take the natural log, bring down the 1 over x, throw in the limit. And that's where we end up right there. So if you did it in steps, this is where you should end up. We've shown that it's indeterminate. We get 1 over 1 plus 3x squared times 6x. And then over the derivative of x is 1. But this is ending behavior as x goes to infinity, so the denominator is winning the race. So 0, but back up here is the natural log, so e to the 0. A lot of 1s for an answer. A lot of powers of e is what you get when you take the natural log of both sides. We're almost out. We're 26 today? Yes. Oh, I'm going to erase this because I'm running out of room here. What do we think about this one? Is it going to converge or diverge? How do you know already? 3 is bigger than 1, right? So 3 is bigger than 1. We know this is going to converge. too bad, because if it was less than 1, we'd say diverge and we'd move on. Limit as a approaches infinity, 2 to a, x to the negative 3 dx. Let's knock this out quick. Kind of running out of time. So we have negative 1 over 2x squared is the antiderivative from 2 to a. So when we plug in a, we get 1 over infinity. That's 0 plus 1/8. So I'll kind of skip a couple steps there. So that one will converge because the power is bigger than 1 in the denominator. All right, let's crank these out really quick, and then we'll be done. I don't even know if we'll have time for this. Convert to rectangular. We have r cosine of theta is equal to 1, so x is equal to 1. This is a line. Now we're looking for that r cosine and r sine. And to do it with this one, we don't need to kind of do something to both sides. We just need to move it over. This one we have to multiply by r on both sides to get r cosine. So x squared plus y squared is equal to 4x. Minus it over. Plus something. 4 divided by 2 is 2. 2 squared is 4. And so we end up with the answer here. Nope, not x plus, x minus. And that's a circle. On the very last one, like I said, I'm picking up the pace because we're kind of running out of time. Limit as a approaches infinity from 2 to a of, well, let's do this. U is equal to x squared minus 1. Du is equal to 2x dx. So we have 1 over 4 through to u du. Now what are you thinking about this problem in general? Do you think it's going to converge or diverge? What are we thinking? It's going to diverge, isn't it? Because that power now is, well, it was before, but the power is less than 1. This is going to be divergent. But let's finish it up. This is u to the negative 1/4. So when we add 1 here, we get u to the 3/4 times 4/3. And now we have that, now it's really going to diverge because we have x squared minus 1 to the 3/4, which it'll go to infinity slowly, but it'll go to infinity. So this is infinity minus, it was 2, not 0, 2. 3 to the 3/4. But that's going to cause it to diverge. There we go. And we got it done. The new stuff, slopes is still dy dx. That has not changed. Slope is still dy dx. Let me stop the recording. And I got a worksheet for you.